Hello everyone, this video is about the intramolecular reactions that could happen with in carbonyl compounds. There are three most common intramolecular reactions that could happen in carbonyl compounds. They are Dieckmann condensation, intramolecular aldol addition reaction, and Robinson annihilation. Okay, what is an intramolecular reaction? If a compound has two functional groups present in the same molecule, then they could lead to the formation of a 5 or 6-membered ring. Okay, intramolecular Claisen condensation is the condensation reaction that happens in a molecule which has two ester groups. So when the molecule has two ester groups present in the same then it's going to undergo Claisen or intramolecular Claisen condensation. And this particular reaction is also called as Dieckmann condensation. Okay. So when two aldehyde groups or two keto groups are present in the same molecule, then the reaction would be an intramolecular aldol addition reaction. Okay, so let's do the Dieckmann condensation. For the Dieckmann condensation, you take either a 1,6 diester or 1,7 diester reacted in the presence of a base. Okay, so you take 1,6 diester or 1,7 diester. You react it in the presence of a base and it's going to form a beta keto ester. Okay, let's do the reaction here. So here is a 1,6 diester. And as you can see, this compound has two ester groups in the same molecule. This compound has two ester groups in it, and when it is reacted in the presence of a base, followed by reaction with the acid, it's going to form a beta keto ester. And here in this case, it's going to form a 5-membered ring structure. Okay, and why this is a beta keto ester? So you have the ester group, and the keto group is in the beta position with respect to the ester. Okay, now let's do the same thing for a 1,7 diester. Okay, this when reacted in the presence with a base, followed by a reaction with acid, it's going to form a 6-membered ring structure. Here again, you have the ester and the keto group, which are in beta position. Okay, now let's go and do the mechanism. The mechanism for this reaction is exactly the same as Claisen condensation, as a simple Claisen condensation. The only difference here is the enolate ion, which is a nucleophile, and the carbonyl carbon, which is undergoing nucleophilic addition. They are in the same molecule. Okay, so I have taken 1,6 diester to show the mechanism. So here is 1,6 diester that in the presence of a base, it's going to go abstract the alpha hydrogen. Okay, so here are the alpha hydrogens. It's going to go grab this alpha hydrogens and thrust these electrons onto the carbon. Thereby forming the enolate ion. And these electrons can come in here, attack the carbonyl carbon, thrust these electrons to form the tetrahedral intermediate. Okay, once the tetrahedral intermediate is formed, we have the leaving group in the molecule, and when reacted with the presence of so here, okay, so the leaving group is going to leave when the oxygen is going to push in the electrons. So these electrons will come up here, and the leaving group is going to leave, forming the alcohol and the beta keto ester. So the reaction as such is, the mechanism as such is super simple. Okay, now let's go on to intramolecular aldol addition reaction. The intramolecular aldol addition reaction is exactly similar to that of the simple aldol addition reaction. Again, here the enolate ion and the carbonyl carbon, which is undergoing nucleophilic addition reaction, they are in the same molecule. Okay, let's do this with 1,4-diketone. Let's draw the structure of 1,4-diketone first. So here is the structure of 1,4-diketone. And why it is 1,4-diketone? Because the second keto group is in the fourth position with respect to the first keto group. So here's your first, if you think this is your first keto group, the second keto group is actually in the fourth position. So 2, 3, 4. Okay, so for this particular 1,4-diketone has two different types of alpha hydrogens. I'm going to show the two different types of alpha hydrogens. So this is a methyl group right there, and I will show these two hydrogens, which are also alpha hydrogens. And the enolate ion that's formed can be of two different types based on the abstraction of the hydrogen, alpha hydrogen. Okay, so now keep in mind that the aldol addition reactions are reversible. Okay, so when a base comes in, it can go and abstract these hydrogens, or it can abstract these hydrogens. So let's do the reaction. Let's write the equation for when these alpha hydrogens are abstracted. Okay, so the OH is going to go abstract this hydrogen, and that's going to form an enolate. Here is the structure of the enolate. Okay, now this enolate, which is acting as a nucleophile, can go and attack this carbon, thrust these electrons onto oxygen, forming the tetrahedral intermediate. So here in this case, it's going to form a 5-membered ring. Okay, so here is the 5-membered ring that is formed, and in the next step, it's going to take in water, where the oxygen, the negatively charged oxygen, is going to get protonated, forming the beta hydroxyketone. So here is the beta hydroxyketone. Okay, now let's see what's going to happen if the other enolate is formed, thereby doing the nucleophilic attack. Okay, so in the presence of OH minus, which is the base, these hydrogens, one of these hydrogens can be abstracted, thereby forming a different enolate. Okay, so this is the enolate that will be formed, and in the next step, it is going to form the tetrahedral intermediate, but here in this case, it would be a 3-membered ring structure. and then it reacts with water molecule where the oxygen is going to get protonated, forming the product. But actually, the formation of a three-membered ring structure is not going to be as feasible as the formation of a five-membered, six-membered, or a seven-membered ring. Okay, so this product is not going to get formed at all. Okay, so what happens when a 1,6-diketone undergoes intramolecular aldol reaction? So the product would be the formation of a five-membered ring structure, because the feasibility of forming a five-membered ring structure is going to be more compared to the formation of the seven-membered ring. Okay, and here are some more examples. When a 1,5-diketone undergoes can also undergo intramolecular addition reaction, forming beta hydroxyketone, and a 1,7-diketone can also undergo to form the respective product.